In this video, we want to look at a couple of diagrams, just some triangles and some kind of weird shapes that we've kind of thrown together. And we have a bunch of missing values, but we're going to find them using what we've seen from earlier in this section. So let's take this guy right here. So this is a triangle that is made up of two smaller triangles. So even though they don't give us a whole lot, and there's a bunch of stuff that we need to find, like they want us to find W and X and Y and Z, it's going to be okay. Because here's what we know. We have a 45-degree angle right here. And because this is a right triangle, that means this guy is also 45 degrees. And because it's 45 degrees, we have a nice special relationship for this. So sometimes it's useful if you just kind of rewrite this off to the side, or just to get a better sense of what that relationship is. So remember the ratios here. For a 45, 45, 90-degree triangle, you would have n for the legs, and then you have n times the square root of 2 for the hypotenuse. So we can use that to answer these questions. So because this is isosceles, this side and that side are the same. So that means that x is equal to 5. So I'm just going to write that over here. X is equal to 5. And let's put that in my diagram. So that's going to be 5. Well, if that's 5, that's really what my n value is, because you see how it matches up in the diagram. So that means that W is matching up with this piece right here, n square roots of 2. So my n is 5. The square root of 2 is going to be constant no matter what. So I just need to write this as 5 times the square root of 2. So this guy is 5 square roots of 2. So we have some good things, and we have like half of this figured out. We've got this other triangle. So you have angle 30, which means this guy is going to be 60 degrees, because you do still have a right triangle because that's perpendicular. And let's make sure we understand what those ratios are for the 30, 60, 90-degree triangle. So you can write this triangle in many different ways. Sometimes people have it where they've got the short side at the base and the hypotenuse is over here or it's over here. Doesn't really matter. I think I tend to write mine like this. So the shortest side is going to be n, and the hypotenuse is going to be double that. And then this remaining side is going to be n times the square root of 3. So figure out where this all fits in with our current diagram. So let's just kind of highlight this. Right now we're looking at this highlighted triangle. Okay, so notice here that the side that I know, which is this one right here, is the side that is opposite the 30 degrees. And the side opposite 30 degrees is going to be that n value for which the other sides are built from. So in this shape, that means that n is 5, which means my hypotenuse is going to be y. My hypotenuse is supposed to be twice that, so twice 5 is going to give me 10. And z, let me do this, z matches up with that guy right there. So what we want to do is to take our n value, 5, and multiply it times the square root of 3. So 5 times the square root of 3. So now we have every value that was missing. We now have that known using these properties and using these ratios from the special triangles 45, 45, 90 and 30, 60, 90. Again, you're going to keep seeing these guys over and over again, so get used to them. All right, now let's look at the other example that we have. This guy looks kind of weird, but it's going to be very similar to the last one that we did. Notice in this example, though, we are given 30 degrees, which means this one has to be 60. And the same thing over here. This is 30, so this has to be 60 degrees up here. So both of these are 30, 60, 90-degree triangles. So let's write that. Where's a good place to write that? Let's just draw that over here. So if this is 30 and 60, that means this guy's going to be n. The hypotenuse is 2n, and the side opposite 60 degrees is n square roots of 3. All right, well, this is definitely not as good as the last one, that's for sure. If I look at the piece that I'm given the square root of 5. That happens to line up with the hypotenuse, which is 2n. So maybe off to the side we kind of work that out. So that means that 2n for this is going to be the square root of 5, which means my n value for this first right triangle is the square root of 5 over 2. So it means that the short side, the side opposite 30 degrees, is the square root of 5 over 2. So that's what this guy is, the square root of 5 over 2. Which means that the side opposite the 60 degree angle is going to be the square root of 3 times that n value. So if I have n times the square root of 3, my n is the square root of 5 over 2 times the square root of 3. Now, remember, this is over 1. You multiply those numerators, you get the square root of 15. This is over 2. You can't simplify that. So y is equal to the square root of 15 over 2. Make sure you understand that 2 is in the denominator and it's not inside the radical. Okay, so we have that first part taken care of. But now we have this. This is messy. It is messy. It just is what it is, though. And I would say, like, you know, why are we doing this? But you know what? I'm the one who made up the problem, so it's really my fault. Sorry. If I look at this triangle that I've now highlighted, my y value, this guy right here, the square root of 15 over 2, that corresponds to the short side of the 30, 60, 90 degree triangle. So this is now going to be my n for the second triangle, which means that my hypotenuse is supposed to be double that. Okay, so actually, you know what, let me just take a moment here. Let me just take this guy, slide him over here. All right, there we go. I feel like I have a whole lot more room now. So if I need to double this, that's just the square root of 15, right? Because if you multiply square root of 15 over 2 times 2, the 2 is reduced. But now I've got to figure out what z is. So z is supposed to be this guy right here, square root of 15 over 2 times the square root of 3. And this gives me the square root of 45 over 2. But we can't leave it like that, because 45 has a factor that's a perfect square, so this factors as 9 times 5. And this gives me 3 times the square root of 5 over 2. So here we have all of the values that we're looking for. There's my x, y, w, and there's my z. So start small, start with what you know and build from there. Make sure that you take the time to draw your picture so you know what the ratios are supposed to be. Figure out what you do have so that you can find out what is the n that connects everything together. And once you have that, you'll be done before you know it.